Hello and welcome to today's webcast brought to you by Fire Engineering. Today's event, Fireground Strategies When Buildings Change the Rules of the Game, will be presented by Anthony Avillo. Anthony Avillo is the recently retired Deputy Chief of the North Hudson, New Jersey Regional Fire and Rescue Department. He has a Bachelor of Science degree in Fire Science from New Jersey City University. He's an instructor for the Bergen County and Monmouth County Fire Academies. He's taught at FDIC and is a member of the Executive Advisory Board of FDIC and Fire Engineering. And he's the author of Fireground Strategies, 2nd edition, and Fireground Strategies Workbook, Volumes 1 and 2. He was a contributing author to Fire Engineering's Handbook for Firefighter 1 and 2, and is co-author of its study guide. And he also hosts the Fireground Strategies radio show for Fire Engineering Blog Talk Radio. So before we start the presentation, there's a couple housekeeping items. At the bottom of your console are multiple application widgets that you can use. If you have any questions for Anthony, you can click on the Q&A widget and submit your question, and we'll try to answer them during the Q&A portion at the end of the webcast. If there's additional resources from this webcast, such as a PDF, you can download it on the resource list widget. It looks like a green folder at the bottom of your screen. You can expand the slide area by clicking on the maximize icon on the top right of the slide area, or by dragging the bottom right corner to enlarge. And in fact, you can expand and reposition many of the components on your screen. So please feel free to arrange them as you desire. If you have any technical difficulty during the webcast, please click on the Help widget. It has a question mark icon and addresses common technical issues. And if you still need assistance, just type your issue into the Q&A widget and our support team will contact you. For your convenience, this presentation will be available on demand within 24 hours. And a reminder email message will be sent to everybody who registered with a link back, and you can get to the archive at fireengineering.com. Now it gives me great pleasure to introduce Anthony Avillo. Anthony?
Thanks, Peter. How's everybody doing out there? Welcome, sports fans. I'd like to thank Fire Engineering for allowing me to do this, and Peter and Tammy for working me through this thing and getting it together. And just a quick shout out to Frank Ritchie, who gave me some good advice about doing these things, and I just want to thank him, my son from Connecticut. All right, so we're going to talk about when buildings change the rules of the game. The slide up right now is actually the cover of the 3rd edition of Fireground Strategy. Should be out hopefully by July or August. I just finished the galleys, and hopefully that's done. So let's jump right into it, as long as I don't have any problem with these slides. I try not to use a lot of text slides, but I use a lot of pictures. Anyway, this is what we're looking at here, and this is what we really want you to get out of this program. The major breakdown with the buildings that change the rules of the game, a failure to recognize when those buildings change the rules. And the problem we run into is we try to fit our common operation to all situations, and I like to call that the 2.5-story frame mentality. And it just doesn't work in the 4 areas that we see below that: the lightweights, the vacants and renovated, the large area, and of course the modern fire environment. The 2.5-story frame mentality has hurt us in a lot of ways in a lot of places. So one of the things we have to be aware of, and you might be a chief officer and understand all these things, but you're not going to be the first one on the scene. So your first arriving company officer is the one that's going to have to recognize this, and his decisions are going to make and break the operation. I like throwing little sort of pull quotes out, and this is one that I really like. Doing things the same way all the time might get you killed some of the time. Your job as a fire officer and a firefighter is to recognize the buildings that change the rules of the game. So now how do we start to recognize this? We want to do that before the Fireground. And one of the tactical breakdowns that occurs is a failure to familiarize with your district. Construction, especially renovation. I mean, you should see these things when they're happening in your district, unless you're turning a blind eye or you're more interested in your cell phone in the jump seat. get inside these buildings, take a look at them. For instance, we're going to look at this building here. This particular building looks like any old, ordinary, normal building. This is downtown Freehold, New Jersey, where Springsteen's from. Anyway, the buildings down there, it's a historic area, so they're all sort of designed to look a little historic. But this particular building here, if you had a fire in the kitchen of that building in the back, and we're talking everyday normal operations, what companies are not going to take an aggressive interior attack on this building and stretch straight through that front door into the back? The second part of that building is sort of an attachment. The building is all the way attached from front to back, and the kitchen is sort of in the back there, so we're going to stretch our line in the back, and we're going to go to work, and we're going to do all the things aggressively that we would normally do. However, if you had looked at this building before the renovation was in place, you would have seen that the back of the building, there we go, the back of the building and the front of the building is attached to what we're looking at right here. The back of the building had a fire. It was a brace frame building, and the second floor is now being held up by wooden I-beams. So, this sort of changes the rules of the game. If you knew this because you were looking at these buildings while they were under renovation, you would know this, and it would be part of your awareness program and your pre-fire planning. This is critical that you know, because an aggressive interior attack in a building like this now, with fires impinging on those things, and by the way, that whole front area of that building, if we just look back at the slide before us, that whole front area right here, that's all lightweight wooden I-beam. And so the back of it, just seeing what was happening there, I mean, you have to recognize that and know that, that's a building that changes the rules of the game. You go in there with an aggressive interior attack and the fire is impinged on those wooden lightweight components, you may be wearing part of that building. So, again, you have to be on top of this in your jurisdiction. Other things to look for. Renovations. Waiting for our slide. Oh, let's push it to the audience here. There we go. All right. Now, renovations, and a lot of these pictures I use in my classes, so you might have seen these before. The idea is, as a chief officer, I want reports from all the areas that I can't see. But this is an old wood frame building. You have a fire going in a cockloft, and maybe the top floor. You can see the smoke coming out of the bulkhead door, which is over in the center of the picture to the right of the guy with the saw. The thing you want to look at here is on the left, in the center of the screen, is an HVAC unit back there. It's probably a 10-ton unit. I don't know. But chances are that building was not reinforced for that unit. It looks like a very old wood frame building, probably 3-story wood frame, and fire in a cockloft. Now, fire in a cockloft, old building, heavy stuff on the roof, those things go together, and they have to equal the possibility of a roof collapse, just because of the location and the extent of the fire. Now, I can't see that from the command post. I would be hoping, and I would have set the expectation for my ladder officer up there, that he better give me a report on what's going on up on that roof. And one of the things I always want to know from the roof is, what's in the rear? Do we have any shafts? Are there any firewalls? But also, one of the most important things is, what kind of heavy stuff is up there that may be detrimental to our operation, especially if it's a fire in a location that it's in right here. We've had firefighters killed when HVAC units crash through the roof, so you have to condition your people to give these reports. This is, again, a building that was renovated, and it's got to be treated a little bit differently. Next slide is actually a building that we had in North Hudson, and this wasn't my fire, but it was one of my colleagues' fires, Deputy Chief Curtis. This building had tin walls, tin ceilings. It was a 2-story building, but when they were on the roof team reported that there was a large HVAC unit on the roof. There was heavy fire on the second floor, and there was fire in a cockloft. They abandoned the operation, and as you can see right here, what happened? The 5-ton or whatever tonnage that is, it don't matter if it's 100 pounds, a hit you on the head, it's going to kill you. That came through the roof, and of course nobody was in the building because we had good reports, and that's what you want to do. You need to have those reports come in, especially your old buildings, and there's a lot of them out there that are renovated with lightweight materials. All right, so let's move on. All right, the next thing we got to look at is, what are they putting in these buildings these days? And this, again, isn't only old buildings, could be new buildings, could be renovated buildings, but, you look at this here and you look at this ledge and you say, well, would I step off a ladder onto this ledge? Well, you might, except when you take a look and see what it looked like before it was it was painted over, it's actually styrofoam. And styrofoam will have a toxic hazard because it doesn't burn, but it melts. It gives off toxic gas and it drips. But it's not going to support you. So one of the things you got to be thinking about is paying attention to when you put the ladder up. When a ladder hits that styrofoam, it's going to sound different than when it hits, a normally solid wood roof or whatever. And this stuff's being used in a lot of different places out there. And again, this changes the rules of the game because if you get off the ladder in there and step on it, you're going to fall. So you have to be aware of that. All right, some other things we're going to look at. Now, this is something that you want to take a look at when you pull up and you do your size up. You look up above that roof, you see what appears to be a pretty large parapet wall. And in reality, what you got to be thinking there is, what's being hidden back there? Right? Why is that wall there when it was never there before? Right? Again, seeing that go up, you'd want to do some investigation. And what are we looking at? We're looking behind the wall now in the next picture. All right, now we're behind the wall. You can see that wall is not brick at all. It's actually some flimsy sort of panel board. I could probably throw a good taekwondo kick right through it, back kick. But this here, if you look at it, this is all HVAC equipment that's laying up and all over this roof. So what was happening in some of these buildings was they were not allowing them to put the HVAC equipment directly on the roof because of the roof load, and if a fire gone through the roof, it caused the roof to fail a little earlier. So they came up with the brilliant idea to put it on an I-beam and then mortar the I-beam into the parapet wall. The unprotected steel I-beam that is susceptible to expansion from heat into a freestanding wall that is susceptible to collapse to begin with. So you see what these renovations are doing to your buildings. So let's take a look now. Now, this was in Weehawken. In Weehawken, they don't allow this anymore. But up in North Bergen, which is, again, one of the cities that we protect, in North Hudson Regional, we cover 5 cities. We cover North Bergen, West New York, Weehawken, Union City, and Guttenberg. We have about 70 or 80,000 people a square mile. We never have a fire without an exposure problem. It's always rush hour. So it's always a challenge. But you look at this particular building. This was, we'll refer to this as the 92nd Street fire. And I refer to this in the new edition of the book quite often because it's a really interesting fire. Anyway, you can see the fire breaking through the roof in a whole bunch of different places. You can also see up on the top in the corners the cell phone equipment up on that roof. One of the problems we had there was the main body of fire. Well, fire was sort of all over the cockloft. It was so intense in the cockloft, the heat, that it was pushing smoke down into the 3rd floor, and there was also smoke coming out of the door frames on the 3rd and 4th floors. But this particular building, if you look at it, had all this cell phone equipment on it, and the fire's going through the roof in a couple of different places, which is indicative of a heavy cockloft fire. And this building was about 150 by 150. It was E-shaped on one side and C-shaped on the other. 5 different wings, railroad type apartments, 10 apartments per floor. But if you look at the left-hand side where the fire's coming out above the roof line there, we'll take a look at the next slide and we get a little closer shot of what was going on there. And you could see that the wall is starting to separate up on the right-hand side. Now, that's not really that common in these type of buildings, unless you have extremely heavy fire. But what we found out in this building was that the HVAC equipment was, again, balanced on an I-beam, which was mortared into the parapet wall. And here you see a shot of the top of the building after the fire. We didn't lose the entire building, but we came pretty close. Again, we had fire in a lot of places and a delayed alarm. But if you look in the right-hand side, I don't know if you can see my arrow on the screen, but you could see the openings, the pockets on both sides where the HVAC equipment was mortared into that wall. All right, so you can see it all right inside that roof there in the wing on the right-hand side of your picture. So, really, if you look at it, if that I-beam wasn't there, the wall would have never been pushed out. But if the wall didn't fall out all the way because it was still tied into the I-beam. So, there was some good about it and some bad about it, but it really, the fact that it was up there was bad. So that building, that was ordinary construction. all right? And that building has since been renovated, and this is what we have now supporting the roof of that building. Come on. I don't know if you're seeing this. There we go. All right, so we had very nice, solid wooden joists in that roof in the beginning of this, before the fire, and this is what we have now. The entire roof is constructed of wooden I-beams supporting, this actually looks like plywood. Most of the time it could be particle board, but this looks like plywood. Anyway, again, not knowing your buildings, another top floor fire, maybe we can't work on a roof, for 40, 45 minutes like we did in the previous fire. In fact, not only maybe, but we can't work on that roof. And again, you got to know your buildings. So you get a fire in a building, 99% of the time, if that building's not going to be demolished, they're going to be renovated with lightweight materials, and it's your responsibility to be out there and take a look at that. All right, let's move on. All right, some of the other things, and we just sort of touched on it a little bit. The things that could be up on a roof are the solar panels, and this is an area where we're still learning about, and it depends where they are. You have them on small residential structures, and you have them on larger buildings like you see on the left. That I think is, I think it's a high school or something like that. But these things are popping up everywhere. They're all over the place. If your department doesn't have an SOP on this yet, you should get one. You don't want to wait until the fire to try and figure out, well, what should we have done? You want to be looking at what we can do and what we should be doing way before thinking about what we should have done. So you want to adopt an SOP in regard to solar panels. I have a little blurb on this here that I got through one of our captains. I'm not sure where he got it, but it's some pretty good guidelines to utilize, and operationally. First of all, stay clear of the panels if possible, and if possible is of course an operative word, because the Fireground is things happen on a Fireground. Cover the panels when feasible, but covering the panels is extremely difficult if you don't have something to cover them with that's big enough to cover them. Most of our tops will have holes in them. Things like apparatus lights at night, flashlights, they can keep these things energized. But look at the shutdowns here. The DC disconnect, the inverter, the AC disconnect, and the main panels. Now, if you're dealing with a big place like a school, you might be able to have access to those things in an area that's not involved. But if you're dealing with a residential structure with these things on them, you may not have access to that due to the fire conditions. So that has to be a consideration. You should never cut solar panels. And for fires, you want to use a 30-degree fog with a 25-foot arc hazard clearance, right? 25-foot arc hazard clearance. So we're talking, I would even go further than that. Use the reach of the stream. And we're going to talk more about using the reach of the stream in some of the lightweight buildings that we talk about. But, again, this is an area that we're still learning about, so we have to really, really take a hard look at this. And if you don't have solar panels in your jurisdiction, you're probably not out looking, because just about everybody has them. So you have to get on top of these things and see where they are, get it into your computer systems, make sure you know about it when you're responding to these buildings, and you'll more likely operate in a proper manner. All right, this is something else that's rearing its head in Hudson County, and sure as other places by us. And that's just a nice picture there of New York City directly across. And you want to geographically, we're located directly across the Hudson River from New York City. So you're looking at it right there. However, what we're looking at here is a roof. This is a green roof. Our entire waterfront is all condos and townhouses and million-dollar occupancies that overlook the city. But a lot of the roofs now are what we call the green roof, and this green roof here, doesn't allow the same easy effort to do ventilation. Plus, it's supported by lightweight C-channel steel beams, and they're very lightweight steel beams. We had a fire in a building like this, and the alarms didn't go off because the fire was up above the top floor ceiling. The only way they knew is there was smoke coming out of the hi-hats in the top floor ceiling. So one of the things we did there, same thing with the 92nd Street fire, the alarms didn't go off there either because the fire was in a cockloft. What we did was we manually pulled an alarm just to notify everyone. Anyway, to us it looked like this fire was through the roof when we pulled up, and struck a second alarm right away. We had the report of the smoke on the top floor, and when we accessed the roof and we utilized the standpipes here, we realized that the fire had occurred through a generator shaft. There's a generator down below that had been running for 24 hours, and it ignited the combustibles around the shaft. And it was rubber roofing and some other combustibles. But one of the problems we had was what you're looking at here is they're sort of like 2 by 2 or 2.5 by 2.5 trays that are about 4 or 6 inches deep that are filled with dirt, and then they grow in them, and this whole roof is just a whole series of those things. So these plastic panels that the dirt was in were all melting all over the roof, and it was snow up there. It was really a messy fire. It was a nothing fire, but we learned a lot of lessons about it. So take a look at your roofs to see what you have that are green roofs, and because in the summertime they may be a little more difficult to deal with because this was the winter, so you don't see a lot growing here. But in the summer, you might have a lot more growing up there. And not only is it a weight hazard, it's going to hold water weight from rain, and it's an access hazard. So again, your ability to be aware of your situation is really to your advantage. All right, let's move on now. Now we're going to talk another tactical breakdown. We're going to talk about the failure to recognize or respect the presence of truss or lightweight construction. All right. Now the first picture we're going to see here is, and I always ask questions in my classes, which I can't do here, but this is a piece of wood from a brace frame building, and this building was well over 100 years old, and it was about almost 140 years old. And if you look at this piece of wood, the rings are really tight. The wood's got a lot of mass to it, and this is what they call slow growth wood. This is, the way God intended wood. It grew in a forest, and it, wound up in a building. But the thing about this, it happens to be a little bit wet, but there's very little moisture in this piece of wood. So any warping or anything that happened to this piece of wood has already happened, as in comparison to what we're dealing with today. What we're dealing with today is called fast growth wood. And fast growth wood is grown on tree farms and impregnated with all kinds of, wood steroids, for lack of a better term, to make them grow faster. And this happens to be a laminated I-beam, which they use all over the place. But what you want to look at here is the amount of moisture in this piece of wood. Look at how wide the rings are as compared to the last one. The last one, the rings are really tight. These rings are really wide. This is more like a wooden sponge. And what's happening is this is what's in our buildings. And while it's in your buildings, it's drying out. And as it dries, it's warping and twisting, and it's being held up by, suspect support mechanisms like, glue and sheet metal surface fasteners or gusset plates or joist hangers. So, these things may be coming, unstable even without a fire due to shrinkage and that sort of thing. And that's not a George Costanza joke, due to shrinkage. So this is what's going on in the buildings they're building today. This is why lightweight constructed buildings change the rules of the game. We can't fight fires in these buildings the way we fought fires in the buildings that were built 100 years ago. They're just not going to hold up certainly not holding up for 100 years, but they're not going to hold up under the insult of fire. All right? So let's move on here. Now, lightweight structures. Talk about those a little bit. How do you tell? How do you tell you have a lightweight structure? And I don't want to hear, we're going to assume or we're going to pre-plan, and those are all really nice. Pre-planning is great, but you don't pre-plan everything. Assuming is the idiot's delight in the fire service. We assume nothing. You have to find out. So how do we tell? One of the things that I would look to do is open up in an area of not involvement, an area that's not involved, and take a look. Open a ceiling tile, open up the roof, take a look in the basement of an uninvolved area, and take a look and see what you got. You cannot operate on the Fireground without all the information. You can't guess. You can't assume. You have to know exactly what you have. Once you figure this out, that we have a lightweight structure, now the rules of the game change. No roof operations except from independent support, meaning an aerial device. Cautious attack from a protected area, right? Years ago, we take the line and we bring the line right to the seat of the fire with about 10 guys with hooks and 7 guys on a hose line and bottles clanging together and everybody's piled into one area, and then we knock the fire down. We start beating the crap out of the room, and all of a sudden, if it happens to be lightweight material, a wall unit or a refrigerator falls through the ceiling above because it was the ceiling joists were compromised because they're lightweight. Years ago we could work for a long time. We can't do that anymore. So what we need to do in these buildings is use the reach of the string. An 1 3/4 line properly charged is going to give you about a 50-foot reach. That's a perfect reach from any doorway, any protected area. These buildings, you need to fight the fire from protected area. You need to hold the horses at the barn door. You need to control the nuts, and you have to make a knockdown from protected area and then a careful assessment of the voids. And why are we doing that? Because we can't trust the truss. You need to assess those voids, right? And I put together this little sort of matrix here, and it's like a flow chart. And the first thing we're looking at here, and it goes right back to our other thing, is how do you tell? Well, first thing we do is we check it out. Is lightweight construction present? The first issue is recognition, just like anything else. If the answer is no, we're on the right side of the screen here, you operate in a safe manner consistent with building construction and structural conditions. That's if you don't have it there. If the answer is yes, now our next question is it involved or is it threatened? And as an incident commander, you probably can't see that. You maybe can see it if there's smoke coming from voids or something, but you need reports. Now, if the answer is no, we're going to increase supervision, put chief officers inside. We're going to operate cautiously, continue to monitor the voids, and reinforce the operation based on conditions. If it is involved, we are then going to withdraw from the area or the building, and we're going to prepare for a collapse. Now, that doesn't mean we have to lose an entire condo complex. That means we're not going to work in the area of origin. We can consider a stop point based on where the fire is, the building layout. Again, if you're dealing with a condo complex, a big building, you should have done your homework here. You should kind of know where you can sort of make that stand, where firewalls are or fire separations or anything along those lines. But this is really your guide. If there's lightweight construction there, we have to find out it's involved or threatened, and that's going to dictate the rest of the strategies that we use here. All right. Let's move on. A couple of pictures here now. All right. Come on. There we go. Okay, now pay no attention to the color of the guy's helmet. I think it's blue, but everybody points out that it's white. Anyway, this is a multiple alarm fire in a lightweight townhouse. And how do I know it's lightweight? Because look inside that circle, you see trusses up there, and they are clearly involved in fire. We also have fire on the right-hand side in what looks like possibly an elevator shaft or a chimney chase, and that's structural areas too. And you look at this guy standing on a porch. Now, the question is, how many people you think are on this Fireground that think it's okay for that guy to be standing there? Obviously all of them, but there's something, inherently and tragically wrong with this Fireground right here because that is being allowed to happen, right? Lightweight constructed buildings, fire in the voids, everybody's out of that area, right? Now, these are some of the monsters that are being constructed up in North Hudson. If you remember the Edgewater fire, it was in a place called the Avilon. And the Avilon was nothing more than sawdust, glue, and a lot of voids. Well, this building here is in North Bergen, and it is an Avalon building. Now, what we're looking at here, it's a U-shaped building. We're looking at the southern sort of wing of the U, all right? Actually, it's more like a C. And what they did with this building is, and this is how to get away with this, it's 74 feet high. So it doesn't have to comply with high-rise codes. It has a one-story, basically fire-resistive parking area because you can't build in North Hudson without having parking. And then what they did was they put 5 floors of lightweight truss and particle board exterior walls up on top of it. So this is what you're dealing with here. It's 74 feet high. I don't know how to get away with this, and this is another shot of it now that it's completed. Come on, there we go. All right, now look at this thing. I mean, really, come on, man. The way we looked at just in the last shot was to the extreme left of the picture. All the way to the right is sort of like the sister side of the C, and in the back is all the other buildings. Now, there's not that many people living in here right now. They're probably too expensive, and I don't even know. There weren't when I was working, but this is one of those buildings that if the fire gets in the voids, just like in Edgewater, that fire got into the voids and it was off to the races. And unfortunately, sometimes these buildings, they're just built with voids. There's voids all over these buildings. So, you have to be very, very careful about, what the extent of the fire is. And you really have to do a lot of recon to find that out. And once that is in place, these buildings can be rebuilt to get everybody out of the building like they did in Edgewater, and by that time that fire was pretty much gone. In fact, if you look at that video, and I showed it in one of my classes in the FDIC, that fire went from, in a matter of about 7 or 8 minutes, it went from one apartment going to like the entire top of the building going. And basically what you're looking at right here was fully involved. So, these are buildings that change the rules of the game, and you can't fight fires in these buildings for a long time because they are just not going to hold up. Right? Now, let's talk about a little bit of a case study here. This was the Rock Harbor complex. Some great lessons were learned at this fire. This, again, is on the Hudson River. You can see Manhattan across the other side. This was a U-shaped complex, and it was sort of on a dead-end road. The road coming into the left, just above the word decentralization, it sort of splits to the right and left, and it horseshoes. There's hydrants down here and everything, and there's really good water down here, actually, because it's at the bottom of the cliffs. Now, what was happening here is you see fire blowing through the roof of this building. Over to the left, you see the ladders going up. We thought this breezeway right here to the left of the fire building was where we were going to have to stop this. The fire is, let's say that was, just the fire building. Just adjacent to that is the Bravo exposure. The Delta exposure you can't see. The command post was sort of in the front, right about where that telesquirt is operating. And if you look over to the right above the bar, you see F&R. That's the New Jersey term for truss floors and roofs. Our buildings, except if it's a single family, they have to have that on them. It's either an F of truss floor, an R for truss roof, or an F and an R for floor and a roof. Only, I think, New Jersey, Florida, and New York State use this. And I don't understand why, because, we've killed enough people in truss collapses, and, I don't know what are the rest of the country doing, keeping this a secret. You need to get this stuff in your jurisdiction. So anyway, this particular fire was moving towards the river, and very lightweight construction. We abandoned the fire area, and we were trying to pinch it off. One of the things I did, which helped me a real lot, was I put division commanders in the Bravo exposure and the Delta exposure. Now, what we're looking at right here is the Delta exposure, and the fire we saw was over to the left in the last slide. I had this particular chief in here, and I was looking at him basically from the vantage point that you're looking at right now. And for me, I was looking and saying, this isn't looking good. This fire really looks like it's starting to take off. What do you think? I'm thinking possible withdrawal from the Delta exposure. And he said to me, no. He goes, listen, I got lines in all the rooms that are exposed to this building. We have all the ceilings down, and what you're looking at is combustible roof fire. Use the telesquirt to knock it down. You can see the water going there. So, one of the things this taught me, and I've always been a big fan of, is get your chiefs off the street and into the buildings. I don't need chiefs in the street. They're nothing more than opinion brigade. Get them in the buildings, and they're going to allow you to make a good stop. Anyway, so this guy was in there. He gave me a very good report, and here's another shot right here coming up to that. All right, here he is right there. You can see him again in the window. Here's the fire going through the roof and the telesquirt operating, right? So this building, we knew that we couldn't operate in that building when you see the fire going through the roof. It was all lightweight truss, and like I said, once lightweight truss is involved, it's over in that area. You cannot be in that area. Eventually, and you talk about lightweight truss, this is what the fire unit looked like. It was an impact collapse. The roof came down, came through the top floor, came through the second floor, all the way down into the first. You can actually see on the walls on the lower floors not even any fire damage. But this, again, reinforces that you don't belong in these units. You don't belong under the fire. You don't belong on top of the fire. You don't belong anywhere near the fire if it's in the voids. And this is what we saw right here. What the vantage point we're looking at is from the opened wall where that chief actually was standing. We opened it up later on just to get stream penetration in, right? But that all having been said, this is the result of that fire. On the right, you see the D exposure where that chief was. On the left, you see the B exposure. Now, this B exposure was really a big problem, and the chief in there was actually thinking about pulling the plug. And you know what really saved everything here and changed everything? Fire broke through the roof. When the fire went through the roof in the building that says Lost, which was the original area, fire went through the roof, the thermal elimination of the heat was just going up through the roof, and the exposure concerns started to immediately improve. we were able to maintain our operations and our positions there. So, you know, you look at this kind of thing, and this is where utilizing division supervisors in the Delta to Bravo, and I had somebody on the Charlie side and I was on the Alpha side, using all those reports allowed me to allow them to stay in and get this job done. You know, but that having been said, we didn't spend a long time in that fire area because it was a building that changed the rules of the game. It was lightweight construction. All right, that was 2000. Let's fast forward 12 and a half years. Here we are again. The original fire unit was the extreme left, and here we are again. This one started about 5 o'clock in the morning. We had another small fire going up on the top of the cliffs up in North Bergen. So all the companies that came down here were 1st and 2nd Battalion companies. We run 3 battalions. So there was a major delay in getting companies down there, so much so that I was down there by myself first. And what I saw was 3 floors of heavy smoke with fire breaking through the wall on the D side of the building, between the floors. So right now we're looking between the floors. We're talking that's a void. I know that's a void, so we immediately have to start thinking this is going to be very similar to the fire we had the last time. And I basically used the same strategy there, right? This is this was in the critique, I guess, that we used, the incident evaluation. We used 6 water supplies here, but you could see here's the fire building here, and the D and B exposures are on both sides. So you can see the command post below it. This hydrant here where engine 9 was attached to it actually was dead at the beginning of the fire, so we actually had to feed that with engine 4. Everything had to be dragged down. Squad 7's the telesquirt. His water supplies up on the top end, and all the way to the extreme left is River Road, where we took 2, maybe 3 more water supplies. The 12 miles in between there, bit of an exaggeration, but not by much, as you're going to see. But this is actually the layout of the property. To the extreme right, at the end of the horseshoe, would be where the river is. I'm going to refer to the inside area as inside the horseshoe, because in order to get there, you either had to come in from the left and go underneath, which you'll see in a second, go underneath sort of like the breezeway. You could see the LDH coming in. All the way to the back is the cliffs. That's where we had additional water supplies coming from. They had to, you know, sort of hand stretch all that in. You see one LDH is charged, the other LDH is not charged yet. Then the other way in was actually from the outside of the building. We were actually looking at the rear of the buildings. We had to stretch into the garages, outside, into the courtyard, back up into the units. A very, very long stretch. This is it's a really cool building, but for a firefighting standpoint, it's not such a great building. So, at the first fire, we had visible fire most of the fire. At the second fire, we were just met with a ton of smoke, and that smoke was from a deep-seated fire, and we knew that the fire was, because we were told the fire was in the voids, and it had started in the room where the heating units were, and they were stacked from floor to floor. And if you look in this particular picture, you can see where the trusses are pulling out. This is the second floor trusses pulling away from the wall. And you can see to the right of that where it's kind of burned. That's about where I saw the fire coming out when I pulled up. So right away I knew we got fire in the voids. I knew it was a lightweight building. And I knew that this, was probably not going to be a long interior operation, especially due to the fact that the visibility was pretty bad. Right, so that's the C side, but it was the operational A side. This here is the inside of the horseshoe. Now, this is how you get into the apartments. You can see the firefighters up on the B exposure, all right, because it would sort of be the D exposure from that side, but the operational side was the B exposure. You can see the heavy smoke in there. Still, a lot of deep-seated fire, and again, you can see from the front. And you can see the building is just starting to pull apart. These were like modular buildings, but they were all lightweight truss, and the building's just starting to pull apart up at the top. And again, you can see where those trusses were off to the side. And I don't know if you can see my arrow. You probably can. But I do have a little bit of video here of this I'm going to show you. It's about 30 seconds worth. That's about all you need to see. Here's the next slide, so hope it comes up.
Sorry to interrupt. The audience cannot hear you. Sorry about that.
Okay. No problem. Can they hear me now? Let's
Yes,
move
sir.
on. All right. Before I get into wooden I-beams, I just want to talk about that video a little bit. You could see how that video collapsed. We already had a sort of a lean-to collapse on the second floor, and you saw how the third floor collapsed and just dropped 3 floors down to 2 floors. We were anywhere near that building. We were well out of that collapse zone. Again, we were pinching it off in the Delta exposure and the Bravo exposure, and it was successful. It was successful, but the key to that is to continue to monitor your voids, because if the voids become involved and you can't keep that fire out of there, you're going to have to abandon those as well. All right, let's move on. Wooden I-beams. Again, the Rock Harbor, which is that complex that we just looked at, Rock Harbor was truss. A lot of the buildings being built today are also being built with wooden I-beams, which are definitely no better. They're used in floors and roof construction. They have a 2x4 top and bottom cord. Sometimes it's 1.5 by 3, more likely. Plywood webs are not being used anymore. It's more a chipboard or an OSB web. Now the adhesive material in there is going to add to your fire load. It's going to burn through very, very quickly, even though it does provide a little bit of fire stopping. Again, a 5-minute collapse potential on these things. They're not. I like to say they're nothing more than sawdust and glue being held together by 2 chopsticks, because that's basically what they are. If you really want to take a look at them, the size of the web in the center, if that's a very big web, they're probably a little bit longer. Normally they're about 20 feet long, but these will collapse without warning. They will collapse without warning, just like the truss. It's not like a steel I-beam. And the next shot we got is a whole bunch of them right here, and these are probably about 2 feet on center, maybe a little bit less, but these are being held up by joist hangers. And joist hangers do nothing but sort of cup the end of the bottom of the joist and just sort of hold it in place with a couple of nails. That's about all it does. And so you can see the collapse potential of these type of things as well. And you have to take a look, what do we have in these buildings? Unfortunately, in New Jersey, and I don't know if it's this way in Florida or New York State, these don't require the truss sign because they're not trusses, although for us they're basically the same, right? This was a fire that we had in a building under construction, and this building had lightweight I-beams as floor supports. You can see the one directly in the center of the picture. There's one to the left, and there's another one that you can't see. There were 3 of these burned away before we even got on the scene. It was about a block from the firehouse. It was a verbal alarm early in the morning, and for these guys, they did the right thing and they knocked it down from a distance, which is what you want to do. Knocked it down from a distance, and you could see the kind of damage that you had there. And there wasn't even any real floor loads on that just yet because the building was still under construction. So, wooden I-beams, they're all over the place. They're extremely, extremely dangerous, right? The McMansion, another one of the lightweight buildings that goes up, and what you got to look at with this building is this is not ordinary construction. There are very few, if any, ordinary constructed buildings being built today. They're just too expensive. So what they do is they put brick veneer on the outside, maybe on the sides too, or it might be a stone veneer. But one of the ways you can tell with these buildings is take a look at the sides and the back. If it's vinyl siding, it's wood frame construction. And again, anybody who's got a little time in the business, you should have seen these things going up on your watch. So if you don't know what they're made of, shame on you. But these type of buildings, they are full of glue-based materials, and they burn like there's no tomorrow. Yeah, anybody who's had a fire in one of these buildings, you're gonna know that. Once the fire takes a hold of the structure, once you flash over and it gets in the voids, it's over. We don't save these buildings. Be honest with you, I have not seen, and there's lots of these buildings down where I live, I have not seen them save one of these buildings. Even if you save 75% of it, the insurance company's still going to tear it down. So, we could do a whole class on these estate homes. Maybe that'll be the next webinar, but, be careful in these buildings. Again, hold the horses at the barn door. I saw a video where a bunch of guys were in here too long and the whole back of the building collapsed, and fortunately for them, they rode the collapse out. But there have been other people that haven't been so fortunate, have been killed in these buildings. They're big buildings, they're large areas. You should be working in there with lifelines. You should be operating from protected areas, and you should be of the mindset that the building is completely filled with voids. And a fire that gets in any void is going to get in any other void in this building. Here's your cathedral ceiling void right here. You can see the particle board roof, all right, up above. And here is another shot of it just from the side. And you can see that particle board. I mean, you look at that stuff, sawdust and glue. You know, if anybody's ever been in a flashover container, that's what we line the walls with. But you can look at all these voids in here. There are closet voids, there are chimney voids, there are floor voids, there are bathtub voids. They're all over the place. You get a good fire in one of these places. And again, a lot of these are in areas, you know, where there are longer response times. Maybe they're not career departments, and it's an even longer response time. By the time you get there, unless there's an interior sprinkler system that didn't allow it into the voids, which is not necessarily you know, that uncommon. You know, these buildings they're killers. They're firefighter killers. They're trusses, they're lightweight I-beams, and you know, we don't belong playing in them for any long period of time. The other thing that happens in these buildings is the top of the building, up in the attic. You never saw this in any other type of building unless it's been renovated, except in these newer buildings. Now you can see the trusses clearly, and they don't really look like 2x4s, do they? The key to these things will be on the outside. How many compressors do you have? If you have 2, 3 compressors, consider you're going to have 2 or 3 zone system, and you want to ask the owner where these systems are. You have a good fire on the second floor, and one of these things is up in the attic. It's pretty heavy. It could lead to a much earlier collapse. So you, again, something we have to be aware of. This is, again, buildings that change the rules of the game. We can't fight fires in them like we normally fought fires in the buildings we have been working in for, you know, 100 years. Steel truss systems. They used to just be in strip malls and warehouses, but they're not just in those anymore. And they're, you know, using them. They're in areas that you know, we weren't used to seeing them anymore in other times. And the other thing with these things is, especially the trusses, it has to do with the codes. How did they get away with trusses? It has to do with the codes. You have your specification code and your performance code. The specification code said that no matter what, you have to use a specific piece of material. So if we say you have to use an 8x12 solid wood joist, that's the only thing you can use in a specification code. But in a performance code, provided the engineering allows for it and the fire tests allow for it, you can use a piece of dog crap if it holds up. Just like what they would say that the specification code would. That's why we're seeing all this weird stuff going on in our buildings, you know. And the other thing with trusses is, you know, why do trusses fail in a comprehensive and you know, a domino type hazard? It's because they're engineered to only hold up the areas that they are holding up. You know, years ago, if you had a legacy roof, a nice solid wood joist roof or wood joist floor, and part of it burned through, that floor's not going to collapse or that roof's not going to collapse. That doesn't happen anymore because when one truss burns through, the ones adjacent to it are not designed to hold up the load of that truss. So if they're designed to hold X amount, and when that truss burns through and now they can hold X amount plus half of that truss, you can see what happens there. And that's why we get impact load and domino type load collapses here with all of this lightweight stuff. So, you know, don't play Russian roulette with this stuff. Don't gamble with it. You know, and I always liken not knowing your building construction to playing Russian roulette. If you're a captain, maybe you only got 1 or 2 bullets in the chamber. But if you're a chief officer on that fireground, like a deputy, you got 5 bullets in that chamber if you don't know the building construction. So playing Russian roulette's a little more of a deadly game once you're on the scene as a chief and there are people working inside the building and time is going by. So know your building construction and pull the bullets out of those guns. Right? So these steel truss systems, they're using all kinds of weird stuff in these things too. Pop rivets, sheet metal screws. We're seeing steel roof decking in places you never saw it before. We're seeing it used in enclosure walls and also in interior partitions. Now, we're also seeing it in places we never saw it before, like private dwellings. These are, you know, estate homes, McMansions, whatever you want to call them. But, you know, take a look at these things, and you know what the only advantage to this is? No termites. That's it. Other than that, this building is going to fail, not necessarily without warning. There'll be some warning because there'll be some sagging, but you can't expect this building to hold up under the fire load. The whole thing is exposed steel, and exposed steel is going to be weak at all times. Right? This was a townhouse going up in North Hudson, and you can see the interior partition walls of steel, very light gauge. The thing with this was one of the roofing structural materials in this building, and it was sort of laying on the floor, and it was probably about, God, maybe 25 feet long, and I could lift it with one hand, and it's just being held together there with those sheet metal screws. And what they did with it was they put it up in the roof. You see it up here in the roof, and this is the first time I saw corrugated steel decking on a peaked roof. These are in condo complexes on the Hudson River. We see it a lot more now, but this is the first time I ever saw it. And here's another shot of it here. But what they did was they just cover it with plywood, and they cover it with asphalt shingle, and it looks like any other roof. You can see the size of the truss loft in there, and look at how thin those steel supports are for that roof. Again, these are buildings that if you don't know what's going on in these buildings, if you haven't seen them when they were going up, this just sets the stage for disaster when we try and fight it like we fought, the 2.5-story frame. These are just dangerous, dangerous buildings. And the other thing is, and this is what happened in Edgewater too, those voids up there are not sprinklered. We don't sprinkle the voids. We sprinkle just unless your code calls for it, which most don't, we sprinkler just the living areas, the common living areas. We don't sprinkle the voids. So just like what happened in Edgewater, once the fire gets into the voids, you got a big problem. And there's a little case study here. We got another one right here. Firefighters narrowly escape a collapse. All right. Now let's look at this building. We see on the bottom right the truss floor and roof sign, and this was on this building. And if you look at it, it says on the left, total collapse of a lightweight truss construction, sending a large portion of the second floor into the first. Upon arrival, the smoke appeared to be coming from between two floors. Now, if it's me, and this is just like Rock Harbor, number one, I know it's lightweight construction. Number two, I got smoke coming between two floors. It's in the voids. Those two things put together equal nobody inside. Everybody out. Everybody stay out. But what do we got going on here? We got guys on the roof. There were guys on the second floor. This is later in the fire. But you look at the third box on the left. Without warning, conditions rapidly deteriorated, and all members were ordered to evacuate. They left tools inside. Guys were bailing out windows. I know somebody that was at this fire said they were very lucky to get out. And what does without warning mean? That means nobody paid attention to anything here. Nobody paid attention to any of the signs, especially that truss sign and the fact of where the fire was. And you can look at this and you can see that, the fire collapsed right down into the garage. Right? This is absolutely unacceptable. This is an example of chiefs playing with 5 bullets in a gun and luckily pulling the trigger when the one bullet wasn't in a chamber. The other thing I looked at is, this was in a place where the academy there trains firefighters extensively on truss construction. There had to be a good, dozens of officers at this fire. How come nobody recognized that nobody should have been inside this building? That's just unacceptable. And this occurred, within 5 miles of where 5 guys were killed in Hackensack and 6 guys were killed in New York and Waldbaum's, and 5 guys were killed in Cliffside Park, all within 10 years, all within 10 miles. This occurred right in that area. Don't play Russian roulette. Know your buildings. Know when it's time to get out. Once the fire's into the truss, it's time to get out. All right, enough on that soapbox. Let's move on. Let's talk about large area structures. This is another one that holds up, that changes the rules of the game. First of all, we got to be looking at what's holding up the roof. Usually it's going to be some sort of truss, whether it's lightweight or bowstring, it's going to be a truss. Search tactics. How far do we enter? How long are our lifelines? So we have 300-foot lifelines, but we're going in with 30-minute bottles. Doesn't make sense. Doesn't make sense. You might be better off doing a multiple entry approach on those lifelines. Hose line choices. 1 3/4 lines. Why are we pulling that all the time? Because that's what we always pull. The pre-connects. Why do we always pull the pre-connects? These are 2.5-inch line fires. Beware of fire above the ceiling. You leave that front door open and that fire is traveling above a drop ceiling. Very similar to what happened in Charleston. That fire is going to be looking, you've established that flow path. That fire is going to go above that ceiling and then it's going to be behind you. Right? Big lines, lifelines, extra chiefs, extra RIC teams. These are what is required for large area structures. Plus, you got to pre-plan these buildings. You got to have an idea of what's in them, how to access them, what the idiosyncrasies are of those buildings, right? You know, statistics don't lie. Twice as many LODDs in non-residential as in residential. And the question has to be asked is, do we go to twice as many non-residential fires? No, not at all. Our bread and butter is still, you know, the residential 2.5-story frame. That's still our bread and butter. We don't go to twice as many non-residential fires, but we're killing twice as many guys there. And why is that? For the reason we're doing this class. We're not recognizing when buildings are changing the rules of the game, and we are operating with 2.5-story frame tactics, right? And, you know, I hate to be a Monday morning quarterback because that's not necessarily really something that should happen in this business. Trying to get this slide to move. Slide's not moving, Tam.
I'm sorry, Anthony, which slide do you need?
59. Sorry, folks, we're having a technical issue here with the slides. We're getting there, though.
You can just call for your next slide from now on.
All right.
I'll push them for you.
All right, I'm looking for 59. Is it up on your screen? Because it's not on mine.
It is on my screen. You might need to refresh your page, but you can continue talking if you'd like and use your backup deck.
Okay. Well, you know what I'm going to do? I'm going to go to my PowerPoint, which is the same, and I think it's the same. It might not be. Hang on here. Let's see. All right. Yeah, I'll just continue to talk, I guess. Okay. Yeah, I can't get to. I got to get to my slides now. All right, give me a second. Let me get to them.
If you try refreshing your screen, that might clear the problem.
How do I do that? Just back out and back in?
Just refresh the page. You should have a little refresh arrow at the end of the address bar.
Oh, yeah.
Sorry for the technical difficulties, folks.
Okay.
We'll be right back with you.
Yeah, all right, it's working now. Okay. Let me bring it up to where I wanted to be. All right, great. We're on slide 59 now. Excellent. Okay. Now, like I said, you know, I don't like the Monday morning quarterback, but one of the things we have to learn is, you know, when these buildings change the rules of the game, you know. We have Worcester on the top, and we have Charleston on the bottom, and we can add to that the Hackensack wall bounce from New York and the Cliffside Park fire, and you know, with 31 LODDs and 5 fires, and you know how many multiple civilian deaths for multiple firefighter deaths. I've been on the job, you know, 30 years, and you know, I have to struggle to remember multiple civilian deaths in buildings like these, and usually we're the only life hazard inside there, and we have to be careful about what we're doing. And you know, in Worcester, there's nothing to do with you know, the Herculean efforts done by the firefighters, but we have to recognize when these buildings are giving us the signs that, like, man, we don't belong inside these buildings. So you know, these buildings that change the rules of the game. This is why, you know, in the Worcester, Mass thing, for instance, Jersey City had a fire in a same exact type building by the Holland Tunnel about 6 months later, and had the lessons not been learned from Worcester, Mass, Jersey City might, or anybody might have wound up losing a bunch of guys there too, because that fire was very well publicized, and you know, you got to learn the lessons that were learned in the past, and you know, those are some of them, you know, and again, the lightweight buildings and using wood frame tactics in lightweight buildings is just, you know, it's just getting us killed, and we can't do that in this day and age, right? I took a couple of seconds about the bowstring truss. The bowstring truss, Waldbaum's, Hackensack, and Cliffside Park, to mention a few. One of the things you got to look at with this building is that, and this is from Vinnie Dunn's book, you know, he explains it perfectly. Failure of one truss will compromise the entire structure and beyond. On the extreme left and right of this building, you have sloping hip rafters, and the sloping hip rafters, they are tied into those outside high parapet walls. These buildings have 4 bearing walls, so if those bowstring trusses begin to fail, they will transfer that load in an explosive manner to the sloping hip rafters, which in turn will generally push that wall out with an explosive force. And Chief Dunn says that should be at 2.5 times the height of the wall as your collapse zone. And out in the real world, this is what it looks like. That sort of sloping roof there, that's what it looks like. Now, interestingly enough, in Hackensack, the firefighters were inside the building when the collapses occurred. In New York City, they were on the roof, and in Cliffside Park, they were outside. In New York, the roof collapsed. In Hackensack, same, and Cliffside, same, but the walls collapsed as well. These are, and the key to this is, what are the conditions? And I remember seeing a video in Hackensack where you could look straight through the building and look at them stretching a line upstairs. And once the camera panned up, you saw heavy fire in the roof area. Fire in the truss areas is always going to be a reason to get out of the building. We have to monitor. We have to make sure that that fire has not entered those truss areas, because that's going to be our key. That's going to be our cue. Fire in the voids, fire in the truss areas are where we cannot operate anymore in those types of buildings. So, again, you may not have any of these buildings in your jurisdiction, but if the jurisdiction next to you has them or surrounding you that you mutual aid to and they have a fire there, you're going to be there. Same thing with a high-rise, same thing with a condo complex. Nobody works without mutual aid anymore except the really, really big departments. So you have to know all of your building construction. You have to know all about how buildings fall apart, because you never know where you're going to fight a fire. And some of these buildings are in horrible state of disrepair. This is a building we had in North Hudson. It's torn down now, but it had a sagging roof, and we went and investigated, and we found there was a broken bowstring truss being held up by a single T-shore, which you see at the bottom of the pictures. Bottom of the picture, and right next to it was the roll-down gate, a roll-up door. And, had we had a fire now, what's the first thing we're going to do? We're going to force the roll-up door. Had they done that, they probably would have knocked that T-shore out and collapsed that roof. So it was, something that we made sure everybody knew about through safety memos on our department. Other large area buildings that are popping up all over the place are these tilt slab or tilt up buildings. These buildings are, the walls are either shipped to the site or constructed right on the site, and they're being held up right now by rakers, right? By these single rakers. Actually, not even rakers; they're just single anchors holding up the wall. But the issue with this is what happens to those walls. What holds those guys in place is when the roof is built. The roof holds the walls in place, and what's holding those things in place to the lightweight steel truss? Nothing but other than maybe some welding or some bolts. Again, all lightweight unprotected steel. And so if you have a fire that's going through the roof in one of these buildings, you have to be of the mindset that these walls are going to come down next. And again, these are buildings that if you're not going in with lifelines as a ladder company, if you're not going in with 2.5-inch lines, and you're not feeding fire department connections, you're going to lose these buildings. Where I work in North Hudson, one of the things that we always make sure of now, and that's one of our ladder policies, is for any large area building, the ladder company has a lifeline with them, and that's even when nothing's showing. Because if you're not bringing it when nothing's showing, you're never going to bring it when there's a fire. It's just like the 2.5-inch line. If you're not stretching it, the large area building, you're never going to stretch it when there's a fire. You have to be thinking, when there's nothing showing, you have to be thinking like a dress rehearsal mentality. You have to be thinking, differently when these buildings are involved. Right? I actually got a little video of this. Some of you might have seen it earlier. Once that fire goes through the roof, we don't belong anywhere near this building. We'll see this again in slow motion in a second. I don't know if you can hear me right now, so I'll talk. All right, so if you looked at that, and I guess you can hear me, if you looked at that, the walls are already gone. The walls are, I mean, the roof is already gone, and one of the walls is already gone. So look at that company, like right there with the tree next to them. I mean, like, where are the officers? Who's in charge of this operation? You know, this is unacceptable. And again, this is complacency. This is thinking that, you know, nobody goes to work thinking they're going to get killed today. But this is sort of, you know, how it happens. You know, by doing something like dopey like this and standing around the wall that's got nothing holding it up. You know, yeah, you know, these kind of things just kill me. But let's move on. All right, some other things, large area buildings, you know, like the Home Depot type place, you know, the lightweight rack storage. Here's another issue that you got to deal with, right? And again, when you're dealing with these buildings, the first due officer is generally going to be the first one in. You know, so if you have a fire somewhere in the center of that rack or something, you know, and let's say it's in a Home Depot and it's a bigger rack and it's got like toilets on it or something, you know, you can't be working inside that aisle because you're actually in the collapse zone. And, you know, you got to use the reach of the stream. You would have to flank these things. You know, and again, this is something you have to drill into your officers because they're going to be, you know, the first ones there on that scene and inside that building. So, you know, you know, when your officers and when your first two companies are not doing the right thing, it's not their fault. It's the fault of the chief officers for not ensuring that they're aware that these things occur. You know, in these large area buildings, you know, they're almost always gonna have lightweight construction in them, but the large area building is, you know, it's where people are going to get lost. And, you know, people going into these buildings without lifelines and with a smoke condition, they're just not coming out. And the other thing with these are, we're going to look at this next video, and I guess you can hear me, so I'll talk a little bit about it. This is called My Last Day at Home Depot. And, you know, let's say you were where that lower pallet is, and there was a fire where the forklift is right now, and you thought, okay, we're out of the way, and we can flank this thing, and we can knock it down from a distance, which is the right thing to do. You got to remember that, look at the guy running over to the left, see him? You got to remember that these things are often interconnected, and this was without a fire. Once a fire starts destroying these things, you know, these things could come down progressively, just like you saw there. You know, these are buildings that change the rules of the game. You know, 2.5-story frame buildings aren't going to work. They're not going to behave this way. But we can't be behaving this way in these buildings either. They just don't allow it, right? Now, here's another thing. You know, wearing this up on a roof. This was in Newark, and my buddy Mike Nasta sent this to me. This was an exposure building. It was at night. And you have to always be aware of your surroundings. And this was a large area, sort of warehouse. It was a one high story, about 30 feet. And you could see there were corrugated fiberglass melt-out panels up on this roof. So what was happening was the firefighters were operating exposure operations on the extreme right of this picture. And they knew these things were there, but because of chatter on the radio, they weren't able to get the information out. So they had the roof lit up, and a battalion chief, who was the safety officer, actually walked up, coming from the left, started walking towards them. And again, it was nighttime. He wasn't sounding a roof. You know, why? Because he's a chief officer. You know, we don't sound roofs. But you know what? We should. I'm not condoning that, right? It's sort of a joke. But he actually stepped and went right through that hole, fell 30 feet, landed on his back, and his injuries forced him off the job. He was like a 28-year veteran. Injuries forced him off the job. So, you know, large area buildings not only have dangerous roofs, but, you know, they're often pretty high, and you know, you never know what could happen on this roof. And you look at this was nighttime. How easy was it to miss something like this? You know, this could have happened to anybody. It's the lesson to be learned here is make sure you're always probing on the roof, no matter who you are. Make sure you're probing, you know, with the weight on your back foot, because even if you were probing and you had all the weight on your front hand, you're going through that hole anyway. So, you know, large area buildings are, you know, just dangerous, and if you're not changing your tactics to operate in these buildings, and that includes when there's nothing showing, you're not going to operate properly when there is something showing. All right, let's move on to the next tactical breakdown. Failure to stretch the proper size hose line. We talked about that a little bit earlier on, you know, and the other thing is, if you're going to be stretching a 2.5, and this goes the same for an 1 3/4 to an upper floor, don't have every engine on a Fireground stretch their own line, because none of them are going to get there. In North Hudson, we use the first 2 engines to stretch the first line. If we're going to an upper floor, we'll use 3 engines to stretch the first line. Nothing more important than the first line. So, you know, if your SOPs call for everybody to stretch their own lines, then, you know, like, you know, smarten up, kid. Get somebody, you know, rewrite it. Everybody should get the first line stretch, especially if it's a 2.5. get that first line in place, and then you can utilize the other lines. The other thing is the failure to utilize a lifeline for search. Do you have a policy? And I talked a little bit about the North Hudson policy. You have to have a policy in regard to this, because your guys going into a building like the one I'm going to show you without a lifeline, they're not coming out. And this building is no different than the Worcester, Mass building, than the South Carolina building in regard to the disorientation hazards, to any other building any other room that's bigger than a 10 by 14 room. Your people, including basements, your people should be going into these buildings with lifelines, with a lifeline mentality. And anybody not on a lifeline better be on a hose line, because there could be a fire in here and you wouldn't even know it. And you can see there's cell phone equipment hanging off the roof here. There's no windows. The worst thing that could ever happen on your Fireground is Mayday, 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 I'm lost. I'm disoriented. I'm running out of air. The smoke is heavy, blah, blah, blah. You don't want that to happen on your Fireground. So make sure you take your opportunity to get done now. What will prevent this type of thing? All right, let's move into the next building that changes the rules of the game, the vacant building. 15% of all LODDs occur in vacant building fires. It used to be something like 18 in every 1,000. That's gone down a little bit because commercial's a little higher, but 15% is a pretty reliable, pretty accurate number. Why is this so high? If you don't know the answer by now, after being in this class for about 45 minutes, then you weren't paying attention, right? These buildings, again, they changed the rules of the game. They're not what they were when we first pulled up on them, right? And you look at a building like this, you know, what do we really know about it? Will we commit our people? But the other end of it is those are occupied buildings on either side. So can we actually let that burn to the ground? Maybe not. Maybe not. But we're going to have to, you know, put division commanders in both sides and seriously monitor that building. But here's the thing you got to take a look at. This building is boarded up. Is it boarded up at the back? No. And the other end of it is, which board do we take off first? Generally, it's going to be the front door, and then we're going to parade in, you know, a whole bunch of firefighters, usually our first alarm response, into that front door with no secondary means of egress, no ventilation. We don't know where the fire is. But what I like to do with these buildings, try and make them behave a little bit before we go in, you know. But again, you got to know your jurisdiction. Like, look at this thing. Look at this building. This is down in Union City, where everything burns, and I came across this building one day, and I had never even seen it before. You know, shame on me, but, you know, like, I'm not sure if it's an old building that's being covered up or a new building that's being covered because it's not in place, but it definitely doesn't look like a place we want to be wandering around in, and that's the key. Your people cannot be wandering around inside these buildings without lifelines, hose lines. You know, find the fire first, then take whatever action you got to take, you know. And you know, life hazard, yes, if there's a life hazard involved and we, you know, we have to risk everything, that's what we do. But, you know, there's, you know, very good evidence that a lot of firefighters are killed in these buildings when there's no life hazard. Later on, during overhaul. In fact, there have been multiple LODDs around the country in buildings that were either unsafe to begin with, or they were nothing more than structural carcasses. I love that term. Structural carcasses when a fire was out, and these guys were still inside doing stuff that actually had no merit. Risk management, boys, risk management, and girls, right? But these are the type of buildings. Let's look at them like, what are we doing here, right? This will help. You have a building marking system. I mean, we didn't make this up. I think we stole it out of New York City and wherever they made it up from, you know. But, you know, this year, this picture tells me you got the roof open, the floor open, and nobody's going in. That's the end of the story, you know, like you know, in North Hudson, we'll change this to, you know, that would be a level 3 vacant, and the used caution will be level 2, and the one with the open box will be a level 1. So we get that over the radio. Be advised to respond to a level 3 vacant. The RO, the FO, roof open, floor open, just at a glance, it tells us what the problems are. Because you know what? There's a fire in here today, but there was a fire in there last week that maybe you weren't at. So you need to know these things. So what are we looking at with vacant buildings? We're looking at a philosophy that I like to use. First of all, open them up before you're entering them. Get them open. Don't allow your people to run around inside these places without you know, protection or knowing where the fire is, because chances are the fire is going to find them first. Strict control over operations. And again, you know, your first alarm companies coming on scene might be there before you. You have to be, you know, very, very very consistent in the enforcement of your SOPs in vacant buildings. Multiple means of egress. Get your RIC team getting ground ladders all over the place and make sure you announce where they are. A very pessimistic approach. And the philosophy you got to look at is don't risk your neck tonight for something that's going in a dumpster tomorrow. You know, again, I recognize there can be life hazard in here, and we're going to take whatever action we can if that's the case. But a very good percentage of these, there is no life hazard inside, and the only life hazard is us. So remember that these buildings change the rules of the game. You know, and make sure you're sizing them up properly. Like you look at this picture here. Now this guy's taking the boards off the window, and that's good. I like that. But take a look above him. You can see on the left it looks like two boots, and on the right it looks like a possibility of a roof attic ladder or something. But look at the holes in that roof. Do you really want that guy there? And if the holes are in that roof, where else do we have holes? So maybe we got to be a little careful. Maybe you do it something like this. You take the boards off from the safety of an aerial ladder. This was a vacant funeral home that we had a couple of fires in, and we had a level 3 vacant on it with an RO for roof open, and we weren't going inside here. So what did we do? Here's the ladder company right here taking the boards off. Look at the fire condition in there, and nobody's surviving that, and we're not going to survive it either. So you have to be of the mindset that these buildings are not the same as they were when they were occupied, and they're probably a lot worse. So what are we trying to get across here? The buildings that change the rules of the game are just, you got to recognize them. You got to know when these buildings are the ones you're looking at from the street. Okay. The other thing is the structural carcass. Again, I love that. But these buildings here, they called them the ice castle. This is a long, long time ago. But when the ice thawed, the buildings collapsed. So the only thing holding these things in place was the ice. And look at the extra weight on the power lines. Here's the philosophy with overhaul of a building. If no one's ever going to occupy this building again, or for a very long time, we have to really question what we're doing inside there, doing overhaul. That's probably the best way I can put it. A hydraulic overhaul might be the best way to go on something like this, a bulldozer overhaul, but people overhaul in a building like that's a loser. It's a loser. And, you have to be careful. You have to strictly control your fireground, and that's a whole nother class. But, recognize that these buildings are just fighting gravity right now, and you don't want to be around them. Okay? You have to do a proper risk assessment. Now, this last thing I'm going to talk about before we go to questions is something that I got from one of our battalion chiefs. They had a fire in a hoarder type building, and similar to what you're looking at right here. And this building was nothing more than, I think it was like 20 by 30. It was a really small building. And if you can visualize the building, the front door was on the A side, and on the B side was like a small sort of like maybe 8-foot alley, and that's actually a wide alley in North Hudson. About an 8-foot alley, and about halfway down was the side door. Now, if you walked in the side door, you went up a couple of steps to the living area or down a few steps into the basement. I am sure everybody can visualize that. So here's what happened. There was another fire going on in the regional, and the battalion chief was there with the 1st Duke Company, and the fire was in a cellar, and it was licking its way out towards that door where, the door was open, and it was the flow path because the line was coming through it. It had a charge line. They were successful in pushing the fire back, but they were running out of air. The battalion was on the landing, and the companies had to leave running out of air, and he was calling for additional companies, but they weren't on the scene yet, or if they were, they weren't dressed and ready to go yet. There was definitely a delay because of the other fire. So the first company leaves, they leave the line there at the bottom of the stairs, and the battalion is standing on the landing. He's calling the next company in, and they're obviously not there in time for his liking, and the fire starts pushing back towards the opening. So he figures, when you look at that phrase, but I just, and this is exactly how he told me. He goes, but I just thought that another company would be there right away. But I just thought if I can just go grab this line, maybe I could push the fire back. But I just thought just going down these stairs wouldn't be a problem. So his mentality, but I just, caused him to take a walk down those 3 or 4 steps. And as he did and grabbed the line, he turned, and his SCBA caught a wall of debris, all kinds of paint cans, all kinds of crap, and it all fell on top of him. Now he's trapped underneath them. He don't have his hands on the line, and the fire's licking above his head, and he had to call a mayday. He was able to get out without, any major injury, but, the lesson he learned that he passed on to me was this but I just mentality. You got to be really careful. First of all, you shouldn't be by yourself, all right? As a chief officer, he could have stood in the doorway waiting for the other companies, and, I get it. But The but I just mentality, you kind of wonder how many people but I adjusted themselves into early graves. You might never know. You're never going to know these things, but these are sort of the mentality thoughts that go through when we're not properly doing a risk assessment. Hoarder basement, no other company available at the time. He got himself in a lot of trouble, and a self-assessment on the risk assessment was. I thought it was great. It's actually part of this is in my new book, and all this stuff is in my new book, by the way, in the 3rd edition. So this but I just mentality, I just want to sort of leave you with that. In summary, here's what you have to do. We talked about buildings that change the rules of the game, and we talked about lightweight construction. We talked about renovated and vacant buildings. We talked about the large area structure, and I actually didn't really have time to go into the modern fire environment, but we've been modern fire environment to death, and that's a good thing, and I hope you have been too, because if you haven't, then you should. But you have to know where the routine operations don't work, and you got to control the nuts, because sometimes the nuts are the first ones on scene, and they're going to go full speed ahead into these areas, into these buildings without thinking, and then all of a sudden something goes wrong and a mayday will screw up your entire fireground. And you don't want that happening. So you have to address these things beforehand, and you also have to address them every single time that you see them either about to happen or they have happened when there was nothing showing. And as a chief officer, sometimes you have to be a pain in the ass. And being that pain will get you people out alive. And I had 2 excellent quotes I'll leave you with before we get into that last little statement. One was from one of my battalion chiefs. It was, I can be your friend and I can be your boss, but if I can only be one, I got to be your boss. And another one was, there's a guy named Frank Vasta. Another one was a guy named Steve Cador, another one of my battalion chiefs, who said, a friend can get you killed, a boss will get you home. So remember the 3 primary objectives. Get them in safe, work them safe, get them out safe. No matter what your rank is, that's your primary objective. Get them in safe, work them safe, and get them out safe. All right, so my email is on the bottom right there if you would like to comment on this. But, I'm going to thank you on this, and we're going to take some questions in a couple of seconds. I just want to take a look at that picture right there. That's in Weehawken, New Jersey. That's the 9/11 Memorial. It's a reflection pool right on the Hudson River, and it was a cloudy day when they dedicated it, but you can see where the World Trade Center once stood, and Ground Zero and the Freedom Tower you can see now. But those are 2 of the only 13 tridents which held at the bottom of the building. Only 13 of those survived the collapse, and they got 2 of them here. And it's really, really touching. It's right between the Lincoln Tunnel and the ferry terminals. And if you're ever in that area, you want to go take a look at this. It's probably, I've seen a lot of them. It's about the nicest one I've ever seen. So that having been said, I'd like to thank Fire Engineering. I'd like to thank Tammy and Peter for getting me through this and helping me with that little technical glitch. And Bobby Halton and all the rest that have supported me. And again, Fireground Strategies 3rd edition should be out by August. So my kids need new shoes. Please indulge me, and please be safe out there. And I guess now we'll take some questions. And it looks like we do have some. So.
All right, Anthony. Well, thank you very much. We really appreciate it. It was a great webcast. And if anybody's got any questions, you can use that widget to send in your questions. We got a couple here. We got one from Carl Wolf, who says he's a former New Jersey firefighter, now a firefighter in Texas. And he says the attic space is being used for the HVAC units, was kind of new. Do you see similarities between attic fires and old school basement fires?
I guess there are some similarities, but to be honest with you, not really, because an old school basement fire is only going to vent into the first floor, and an attic fire is going to vent through the roof and make things a little bit better. And an HVAC system, and maybe I'm not catching his question properly, but an HVAC system in the basement isn't going to fall through the floor, but an HVAC system in the attic is going to fall through the floor. So I'm not so sure if there's that much of a difference, other than you're dealing with areas that are difficult to ventilate, and and are starting to hold some. They are starting to hold some of the same hazards.
Okay, and I think we've got a lot of people just asking about having SOPs for the solar panels, and I just want to remind everybody that I think this is available as a PDF, so you should be able to, if you were looking not for the SOPs themselves, but if you wanted to rewatch this, you'll be able to watch it on demand, and this entire presentation will be available as a PDF anyway. But do you know, Anthony, where people will be able to go to get SOPs for the solar panel kind of response issues?
We didn't have one in North Hudson, but you know what I've always done? I go on the fire engineering training community. I go on the bulletin board, and I just ask, does anyone have an SOP on solar panels? Does anyone have an SOP on tiller operations? And if it's out there, you will get it. You will definitely get it. It's going to be your best source.
Okay. And by the way, talking about the Rock Harbor fire, I think you wrote a piece for Fire Engineering magazine a couple of years back. I think it was the August 2013 issue, right, on that?
I believe so. Yeah, August 2013. It's funny because I was just looking at, somebody sent me a picture of that cover, like on a plaque. And I just looked at it the other day. I believe it was August 2013. And that whole fire can be, it's a lot more in depth in the article.
And we got one more question. This one's kind of a big one. But is there anything the fire service can do to change the codes and regulations concerning how the building industry is making these type of buildings, the lightweight buildings and such?
Well, after the Edgewater debacle, there was a pretty great cry across Bergen County and across the state to, provide sprinklers, provide firewalls every so many units. And, some places do have that. New Jersey doesn't have that. And, unfortunately, from my experience, once a week or two has gone by, politicians forget about all this anyway, and people are onto something else. So do I think anything is going to occur from it? No. The only thing you can do is lobby your politicians. That's the only thing you can do. I mean, they were able to get the Truss signage passed in New Jersey. That was done with the help of the IFF and imagine the FMBA, and the unions were involved in that. And we do have some friends, believe it or not, in New Jersey that are still friendly to the fire service. Certainly not the fatso governor, but or the judges anymore. And but we do still have some friends that assist us in some of these things. And you got to find who your friends are and push your agenda with them.
All right. Well, thank you very much once again for this webcast. I think we got through most of the questions, and if not, perhaps Anthony, you can answer them offline, and we could put them up on fireengineering.com if that's cool.
Mm-hmm. Yeah. You just got to let me know how to get to them. That's all.
Oh yeah. Well, we'll send them to you. We'll forward them to you, and the feedback. There's a lot of good feedback from this class. So
super.
So on behalf of Fire Engineering and Penwell Corporation, I'd like to thank Anthony Avillo for today's presentation. This presentation will be archived within 24 hours, and you can access it from the homepage at fireengineering.com. And a reminder email message for the archive will be sent to everyone who registered, complete with a direct link to the archive. Thanks for joining us today, and we look forward for future webcasts.
Thank you.